So today we will start with a revision of binomial theorem. So first of all, two main things that we cover is general term in the expansion of x plus y to the power n. General term in the expansion of x plus y to the power n. And that is tr plus 1 term, and that is ncr x to the power n minus r y to the power r. Am I clear? So just on the concept of this general term, today we will cover mainly questions of general term, finding power of a particular term, and term independent of x, number of irrational terms, and rest of the things. So just remember, this is the general term. Total terms in the expansion will be n plus 1. Total number of terms in this expansion will be n plus 1. Now see a question. A question is, let m and n be the coefficients of 7th and 13th terms respectively in this expansion. Then find the value of n upon m raised to the power 1 by 3. This is a like 1 year back, this came in JEE mains only. Give it a try. You have a couple of minutes for you. Give it a try quickly. Let m and n be the coefficients of 7th and 13th terms respectively in the expansion of this. Coefficients of 7th and 13th terms. Just quickly try. All right, so let's do it together. First of all, m and n be the coefficients of 7th term. So first of all, I write 7th term. 7th term will be 6 plus 1 term. Yes or no? That is 18c6 x to the power 1 by 3 upon 3 की power 18 minus 6, 12, and 1 upon 2x to the power 2 by 3 whole raised to the power 6. Understood? So that is 18c6 1 by 3 की power 12, 1 upon 2 to the power 6. Don't solve it initially. Fine. Into x to the power, here it will be 4. In the denominator, it will be x to the power 4 again. 3 to the 6, x to the power 4. This is cancelled. So coefficient is what? 18c6, 1 upon 3 ki power 12, 1 upon 2 to the power 6. And this is your m. M be the coefficient of 7th term. Now let's come to coefficient of 13th term. So 13th is t12 plus 1. That is 18c12 x to the power 1 by 3 upon 3 raised to the power 6 into 1 upon 2x to the power 2 by 3 whole raised to the power 12. That is 18 minus 12, 6, and here it is 12. So this will be 18c12 1 upon 3 ki power 6, 1 upon 2 to the power 12 into x to the power 2 upon x to the power 4 to the 8. Am I correct? So in that case, coefficient is what? N. That is 18c12 1 upon 3 to the power 6 into 1 upon 2 to the power 12. Correct? Now they are asking you for m upon n. M is what? 18c6, 1 upon 3 to the power 12, 1 upon 2 to the power 6, divided by 18c12, 1 upon 3 to the power 6 into 1 upon 2 to the power 12. Now, if you remember, this 18c6 is cancelled by 18c12. So, what I am left with? 2 to the power 6 upon 3 to the power 6. They are asking for n upon m. N upon m raised to the power 1 by 3. So that is 3 to the power 6 upon 2 to the power 6 whole raised to the power 1 by 3. So that is 3 by 2 raised to the power 2. Answer will be 9 upon 4. Answer is what? 9 by 4. This is your daily answer. Have a look at it. Very good question. Very simple question. And totally based on one simple concept of the general term. Check it out quickly. Fine. Now, let's try this question. The question is, number of integral terms in the expansion of this is equal to. This question also placed in JEE mains exam 2 years back. Give it a try. They are looking for number of integral terms. Integral terms, number of integral terms. Quickly. First of all, start with writing the general term. Now see, let me do this one for you. Now, first of all, what is the general term? General term is TR plus Punnett term. That is A24CR 7 to the power 1 by 2 raised to the power A24 minus R 11 to the power 1 by 6 whole to the power R. Yes or no? Now it is A24CR 7 to the power. This will become 412 minus 2R minus R by 2 into 11 raised to the power 6 by R. Now see, first of all, for the term to be integer, this power should be integer. Now this is not 6 by R, this is R by 6. R upon 6. So first of all, this power should be integer. Now that means R by 6 should be integer, and your R lies from 0 to inclusive of 0, 0 to 824, correct? Now R by 6 should be integer. So if R by 6 should be integer, that means ki R is an even number at least. So in that case, this 412 minus R by 2 will definitely be an integer. So I don't have to think anything about it separately. Understood? So what do you get? You want R by 6 to be integer. So that means if R lies between 0 to 824 implies R by 6 will lie from 0 to 0 to 6 1 ja 6, 6 3 ja 18, 44, and 6 7 ja 42. Am I correct? So from 0 to 137, there are total 138 values of R. So total 138 values of R for which 138 values of R for which term will be integral. Understood? For which term will be integral. This is a high weighted chapter in JEE Mains. So total 138 values of R for which term will be integral. Am I clear? Okay, since this has been a pretty easy question, let me make it little difficult for you. Let us do 7 raised to the power 1 by 7 plus 11 raised to the power 1 by 11 whole raised to the power, let's keep the power same, 824. Now tell me total number of integral terms. Find it. Total number of integral terms. Now attempt it. Yes, quickly. 7 raised to the power 1 by 7 plus 11 raised to the power 1 by 11 whole raised to the power 824. Yes, yes, quickly, quickly. How to do? Now see. Now if I talk about the general term, that means TR plus 1 term. It is 824 CR 7 to the power 1 by 7 to the power 824 minus R into 11 to the power 1 by 11 whole raised to the power R. This will come. That is 824 CR 7 to the power 824 minus R by 7, 11 to the power R by 11. Now for the term to be integral, this power should be integral as well as this power should be integral. Yes or no? So what do you want? R by 11 should be an integer. And here you want 824 minus R by 7 should be an integer. So in this case, if I see R can be 0, then directly R can be 11, then 22, up to, this will go up to which point? R lies between 0 to 824. 0 to 824. So if I divide by 11, 11, 7 just 77, 88, 89, 90, 90, 54. So 11 4 is 44. This will go up to this point only. So there are basically total 75 values of R for which R by 11 is an integer, including 0, 11, 22 and so on. Now you have to consider this also as an integer. This is bit of tough. So let's do one thing. Divide it by 7. 7 1 just 7. 8 1 12 7 117 plus 6 plus 5. R will be this is 7 into 117. 7 into 117 plus 5 minus R by 7. It should be an integer. That means this is 117 by 7 is already divisible by 7. So you want 5 minus R by 7 should be integer. Am I correct? Now in that case, what R can be? See, the first value of R can be 0 won't work, 1 won't work, 2 won't work, 3 no, 4 no, 5 no, 6 no. Wait, first value of R that will work is 5. Because see, if I place R as 5 here, it will be 719, which is divisible by 7. Oh, sorry, 819, which is divisible by 7. So first value of R will be 5. Now the next value will be 12. Then 19. Then 19, then 26. Then 30, 33, and so on and so forth. And the last value of R which is going to work here is 890. Yes or no? Now what you have to consider, you have to find the common terms in these two. Yes or no? So the first common term that I find is 33. And see, first जो AP है, that is 0, 11, 22, that is having common difference 11. Second AP having common difference 7. So the AP which is consisting of their common terms will be having common difference as 77. So after 33, next term will be 110 directly. If you add 77, 110. The next common term will be 187th, when R will be 187. And you can check it. Anyhow, you can check it in between, wherever you feel like. Then 187 plus 77. Next week, because see, if you try to find using the last term, that is again a task. So better we do it this way only. So it is 187 plus 77. Next will be 264 value of R. Next will be 341. Next will be 418. Next will be 495. Next will be 572. Next will be 649. Next will be 726, but we are close to almost an end. And the last will be 803. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11 values of R. That means there are total 11 terms which are integral, where there is no radical sign. Understood? Now let's jump to the next question. See the next question. Give it a try. Very easy question again, but this question is from JEE Advanced 2023. And very simple question. Just quickly try. Yes, yes. Now, if the coefficient of x raised to the power 7 in this, so first of all, let's try to find the coefficient of x raised to the power 7. So writing the general term tr plus 1, 13cr ax raised to the power 13 minus r minus 1 upon bx square raised to the power r. Got it? So it is 13cr a to the power 13 minus r upon minus b to the power r x to the power 13 minus 3r. So first of all, what do you want? This 13 minus 3r should be 7. So 3r is equals to 6, so r equals to 2. So that means now we can find the coefficient. So coefficient of x to the power 7 is 13c2 a to the power 11 upon minus b to the power 2. Correct? Now come to second term. There r plus 1 term is 13cr ax to the power 13 minus r and 1 upon bx square to the power r. So it is 13cr a to the power 13 minus r b to the power r into x to the power 13 minus 3r. Now what do you want? This 13 minus 3r should be minus 5. So 3r is 18. So now r equals to 6. Understood? So now the coefficient of x to the power minus 5 will be 13c6 a to the power 13 minus 6 is 7 upon b to the power 6. Got it? Now they are saying these coefficients are equal. That means 13c2 a to the power 11 upon b square is equals to 13c6 a to the power 7 upon b to the power 6. First of all, you cancel this, you get b to the power 4. Then you cancel this, you get a to the power 4. So a to the power 4 into b to the power 4 is 13c6 upon 13c2. So 13 into 12 into 11 into 10 into 9 into 8 upon 6 factorial. Here it is 13 into 12, upside goes 2 factorial. So 13 and 12 cancel. You are left with 11 into 10 into 9 into 8 into 2 divided by 6 into 5 into 4 into 3 into 2 into 1. Got it? So 5 to the 10 cancel. 6 4 the 24, 4 to the 8, 3 3, 3 to the 6 to 6 cancel. So your answer is 11 into 2, that is 22. That's it. Very easy question. Got it? Have a look quickly. right? Okay, so that would be all for today. Thank you so much.